Hi everyone. So this is the second part of this lecture, right? In the previous lecture that was going 1 hour, so I had to take a break bit of. I had an urgent work, so we'll restart the lecture B only. This will be part B basically. So I gave you a few homeworks, right? So yeah, we'll solve those and we'll solve the questions basically. So this is the first question. So how did you solve it basically? If you solve it like this, there are two transfer functions, right? And there is one input, and you can do a bit of sort trick also. What you can do is you can find the order of the order of the transfer function, the order, right? If both of them has s to the power of 1 in the denominator, so the order n, the value of n will be 1 only. Okay, value of n will be 1 only. Okay, so if n is 1, now I have two outputs and one input, right? I have two outputs and one input. So okay, let me solve this using two methods. One is using option and one is using conventional method. So option, right? Option is, this is the method 1. And so this is the method 1, right? So method 1, we have how many number of inputs we have? Number of inputs we have 1 and number of outputs we have 2, right? So inputs, right, we have 1 and outputs we have 2. Okay, and what is the order? Order is 1, as both this, right, both this transformation of order 1, right? So that's why. Okay, that's why. Okay, so this is also s to the power 1, this is also s to the power 1. And one more thing, what you can do is you can assume a x state variable here, and this is going directly here. So we have only one state variable, one x. Okay, this is also equals to y1 directly, and this is also equals to y2, this x, right? If I assume x over here, so yeah, there is only one state variable. Like that also you can understand, like this also you can understand, there is only one by s term between u and y. Okay, both of this u and y. So like that you can also understand. So the order, right, will be 1 as both of them as 1 versus 1. Okay, so yeah, so yeah, this one is this one. So now, right, now we can solve with orders. I was just ख्यालों में खोया था थोड़ा सा. तो yeah, this, right, we have this, what will be order of y, order of y, right? Y will be this 2 cross 1 matrix, right? 2 cross 1 matrix, simply p cross 1, that is. So my c, right, she should be p cross n. So this should also be p is 2 and this is 1, so p cross 1. Okay, where is my c1? C2 cross 1. 2 cross 1 means 2 rows and 1 column, right? So if this is x only, x is 1 cross 1, right? 1 cross 1. So what I see over here is 2 cross 1 is present in these two, right? Option B and option C, D, right? So both of these can be possible, but the one problem is this x matrix is 2 cross 2, which is not valid, right? This will be the answer, right? This will be only 2. This will be only 1 cross 1. Also we can see only one input variable is coming over at this point, right? We have only one node. So also this is also 1 cross 1, and my basically n will be 1 cross 1. So what I can write here is that x dot, right, x dot will be 1 cross 1 only, which is equals to a, which will be also 1 cross 1 only, and this is times x, which is 1 cross 1 only, plus b, which is input m cross 1. So m is 1, m cross n basically, sorry, m cross 1. Sorry, I'm again saying it wrong. It is basically what do you say, n cross m, right? N cross m. Now n and m both are 1, so it becomes 1 cross 1, and this is u. U is only u only. Okay, u is m cross 1 only, so it is 1 cross 1. So everything is 1 cross 1. So 1 cross 1, everything is only here. Okay, only here, and this is 2 cross 1, right? So from here, what I can say is that I can eliminate the options, and I will get my answer as B, right? I will get my answer as B. Now, right, now what if I want to you say no sir, I don't want to solve it like this, I want to solve it conventionally, right? So in gate, right, you don't argue with me, you solve it like this only. Okay, because this will save you time. Okay, so as I was explaining it to you, that's why it took me time. So yeah, finding the order and then assuming x state variable here, and finding p, m and n and writing the equation, all this took me time, but you will solve this in seconds, right? So what is the method 2? Method 2 is conventional only. Okay, what you will do, you will assume a state variable over here. Okay, I will copy this picture and paste this over here. So if I paste this over here, so what I can do, I can assume a state variable at this node of x, right? At this node of x. Okay, if I assume a state variable over here, so what will happen? U will be equals to x only, right? So u will be equals to x only. So that's why, like, let me assume this as x dot. So x dot will be equals to u only, and I won't be able to directly integrate this. So what I will find the relation here as is like, what is the relation? The relation, right, is simply y1 equals to 2 by s plus 2 times x dot, and y2 equals to, okay, I'm writing this wrong, 2 by s plus 2 x dot. So like the relation between, what is the relation between y1 and y2? Simply the relation between y1 and y2 is that y1, or you can say y2 equals to 2y1, right? So whatever the matrix is there, right? So the number of, I know we have two number of outputs, and one output will be twice of the other one. So from the options that I can see is, this one is the twice of the other one. Okay, this one is also twice of the other one, but here, right, we have only like one, like on one state variable, right? One x dot. Okay, one x dot. I won't be able to directly write this relation. Okay, difficult for me to write. Okay, just by this. Okay, we have only one state equation. So yeah, this will be my option B. Okay, this will be my like option B only. So we have only the order of the state variable is 1 only. So yeah, this is my option B here. Okay, so yeah, this is my answer for this question. So I will further like take this question in some other time and like modify this, and we'll do this in a much like, I will explain it to in a much deeper manner, as like this, like chapter is already going long, so I won't explain this further. So yeah, this is why this with the help of this relation I can solve for the question, right? So like, let me write here also that y1 and y2, right? y1 and y2 equals to 1 to x. Okay, y1 to 1 to x. So let us go to the next question. So what is the next question telling us? This is also gate easy question, very like old question. For the system described by the state equation, x dot equals to 0 0 0.5 1 0 1 0 1 2, and this is 0 0 1 u, right? Now, right, if the control signal u is given by this, so control signal is also given in relation with the state variable and v. Okay, then the eigenvalue of the closed loop system. Okay, the one thing, the confusion is it didn't tell us anything about the v. Okay, basically, right, once what does this question mean by eigenvalues of the closed loop system? So right, basically you have to find the transfer function, the poles of the transfer function. So eigenvalues are poles of the transfer function that I explained, right, that I explained in 2-3 lectures ago. So yeah, that is what is telling us to find is, first we'll find, like, we'll put this value of u here, because this is just a control signal. Okay, this is a control signal and this is the input, v is input. This question didn't tell us that. Okay, and like old questions, the complete information generally they don't give. Okay, but yeah, this is my input and this is simply my my control signal, right? So how to find the closed loop eigenvalues of closed loop function? Just find the poles of this, right? Characteristic equation, we have to find just the characteristic equation, right? So if you remember, mod of si minus a, we equate it to 0, and from there we'll find our poles, and the poles are eigenvalues, right? Poles are eigenvalues of the closed loop system. Okay, that we have already derived very well, okay, in the previous lectures. So yeah, what I will do, first I will replace this u with this here, then add these things, then I will slowly like change, right? So yeah, let me like copy this matrices. Copy this one equation. Okay, so yeah, so what is like I will replace u here. So what will I get? This is equals to x and 0 0 1 multiplied by this one, right? So what will this become? This is a basically 3 cross 1 matrix, and this is a 1 cross 3 matrix, right? 0.05 minus, okay, I don't have enough space, I have to reduce the size of this one. And like this is x, okay, and this is plus v, okay, we have plus v also. So like this, what will this become? This is 3 cross 1 and this is 1 cross 3. What will this order of the result become? What will it become? It will become 3 cross 3, right? So it will become 3 cross 3. So yeah, let me first multiply this one. So I get here, okay, this one is copied only, this one is same only. I will add this slowly. So this is basically 0 times this, okay, row times column, right? This is 0 times 0.5, yeah, this is done. Okay, now what will I multiply? This is 0 times the next row times column, sorry, this is this one only. This is 0 times 0.3. So what do I get? So I get here is, let me write this, this will be a 3 cross 3 matrix, okay. And the whole row, right, will be multiplied with 0 0 0. So this whole upper row will be 0 0 0 only, right? So don't get confused, right? This 0 times this one, first column is done, then again this row into this one, this is done, and this one, this is done. Again the second row is also 0 0 0. So second row will also be same only, 0 0 0, okay. Only the third row is changing. So third row is 1 row into column, then row into column, then row into column again. So this whole row is getting copied. So minus 0.5, minus 3, and minus 5, and this is x only, plus v, and yeah, plus with plus v we have this 0 0 1, right? This 0 0 1. So yeah, okay. So yeah, so like this is how we solve this matrix, right? This is how we solve this matrix. So basically, right, just take care of this one, okay? If you don't understand this matrix multiplication, like sometimes happens, like confusion happens. So this row, right, this row will be multiplied with this all the columns, right? Each elements, okay, each element we get. Now we will go to second row, then we will third row, okay. That's how we go, right? So first row into column, then what happens is like second column into second element. That's how it happens. But yeah, we don't have second column, right? That's why we multiply with this one, and yeah, we end it there only. Then again this row into this one, okay. That's how we go. So yeah, that's how we do the matrix multiplication. So yeah, let me add these two up. So what will my x dot become? 0 1 0, okay, 0 0 1, and this is 0, this becomes minus 2, and this becomes minus 3, okay. So minus 2 3 0. Now this is x only, plus this is 0 0 1, okay, this is v only, okay. So now my v is the input, right? V is the input, and like from here, like this is the actual state equation. this is the actual state equation, not with respect to control signal. U was the control signal. So now let's find the basically poles, right? So like the poles will be simply the roots of the SI minus A inverse, right? So if I do SI minus A inverse, or if I do SI mod, so SI minus A mod, so determinant, find the determinant. So this is S minus 1 0 0 S minus 1, this is 0 2 S plus 3. Okay, this is equals to 0, right? So let me solve S into S plus 2. We have to find the roots of this one, right? So what are the roots of this one? So this is equals to 0. So one root is S equals to 0, right? One root is S equals to 0. Now if S is not equals to 0, S is not equals to, then this equation will come in handy. This has to be 0, right? If this is 0, then yeah, this is done, right? This equation is done. Now if this is not equal to 0, I can simply divide both sides by S, right? That is not an issue. If this was equals to 0, I couldn't have divided by S. Okay, I can't divide by 0 in both sides, right? So yeah, one equation, this one. Now this one is S square plus 3S plus 2 equals 0. Now this is simple to solve only. So like this is S1, now S2, right? S2 is, let me write this as lambda 1 only. Okay, lambda 1 and lambda 2. Okay, this is like simple only. Lambda 2 equals to 2 and let's say lambda 3 equals to 1. Okay, so okay, I think they are minus 2 and minus 1. Okay, they are minus 2 and minus 1 because the sum will be negative of this, right? So I hope you have like you remember the form, right? Here what form comes here? It is the sum of the eigenvalues negation, right? In negation. Okay, as there is S cube also, so that's why. So this was the S square coefficient, if you remember. This is the S cube coefficient. If I multiply S, okay, S cube, this was the S square. So what comes with S square? It comes sum of the eigenvalues in negative sign. So the sum of the eigenvalues in negative sign will be minus 2, minus 1, minus 3, and negative sign becomes plus 3. And like what was this? This was the product of individual eigenvalues. Okay, so 2 times 1, then we have 1 times minus 1 times 0, like minus 2 times minus 1, then we have minus 1 times 0, and also minus 2 times 0, that is 0 0 only. So we are left with only this one. Okay, that's why this is not the determinant, right? This is not a determinant of this matrix. Determinant is 0. Determinant is 0, right? I hope you understand, because we have one eigenvalue 0, so the determinant of the system matrix will always be 0. Okay, I hope you understand, right? So yeah, like from here also, if you see, like there is some linear combination, so the determinant of system matrix will always be 0. Okay, so like not system matrix, sorry, one of the eigenvectors will always be dependent on the other two, right? On the other two. That is what that means if the determinant is 0 of the like this equation SI minus A inverse. Like if one of the eigenvalues is 0. Okay, so let's not get diverted. So what is our option? Option is like minus 2, minus 1, and 0. So this is our option, right? Minus 2, minus 1, and 0. Okay, so sorry, like if the lecture feels a bit like jittery, because I'm a bit tired actually. So this is actually like 2 AM in the night. So yeah, okay, this is another question. What was the question number here? It was 28. This is 29. So this is also a gate E question basically. So what is this question asking us to find is, like this is the last question I think. So we have a state variable system x dot of t and e of t. So we have been given x of 0 and input unit step, right? And input unit step. Okay, so what do you have to find? Like input is unit step only. We have given initial conditions also, and we have given the state transition matrix. Okay, sorry, state space equation basically. Now what we have to find is, okay, this is 29. Okay, sorry, what we have to find is the state transition matrix. We have to find the state transition matrix, right? So the state transition matrix we have to find, that is simple only. Just do SI minus A inverse, that is our state transition matrix, or what you can do, use properties. And second, find the state transition equation. I mean, it is telling us to find the the value of state variables, right, in terms of time. Okay, so first, the first part is easy only, right? First part, you put like what are the properties. If you put t equals to 0 in a state transition matrix, you get the, what do you get? You get the identity matrix, right? So if I put t equals to 0 here, what do I get? This is 1 only. Okay, fine. If I put t equals to 0 here, you get 0. Okay, fine. This is 0 and this is also 1. Okay, this a can be one of my answers, right? This a can be one of my answers. Now I have to check for other options also. Okay, now if I put t equals to 0 over here, this is 1 minus 1, this is also 0, this is 0 and this is also 1. Okay, so again this can also be my answer, right? If I put t equals 0 here, this can also be my answer. Okay, if I put t equals 0 here, this can also be my answer. So gate people are smart. Okay, they know, you know the basic property. If you put t equals 0, yeah, we get identity matrix. But now you have to be more smart. What you'll do, you will use a second property. So what does the second property tell? The differentiation of state transition matrix will be our system matrix only, will be our A matrix, this one, this matrix. So now if I differentiate this one, what do I get? I get 0 over here, I have 0 over here, yeah, I get minus 3 e raised to power minus 3t at t equals 0, right? T equals 0, we get system matrix A. So this is minus 3 e raised to power minus 3t, so this becomes 1 only, this is minus 3. So yeah, we have minus 3 over here. This, no, this is not correct. Okay, that's how I will do. No, it's not like I will check all the elements. I will check the easier elements and run away to the next question. That is how you should solve in exam, right? So differentiation is minus 3 at t equals 0, this is minus 3 only. Differentiation is minus 1 and t equals 0, this is like minus 1 only. So this is not the answer, right? By minus 1 I mean minus 1 e raised to power minus t, and this is minus 3 e raised to power minus 3t. Okay, so this is minus 3 and this is minus 1. So yeah, this is correct. And what is this? So this is right. This is basically, if I do differentiation of this, yeah, this also becomes minus 3t. Okay, this also becomes minus 3t and this is minus 3. Okay, this, like this is also e raised to minus 3 minus 3. This is rejected. Now I am left with these two, right? So now I have no other option, I have to solve this one only. So if I solve this one, what I see is the differentiation of this one is 0, but the differentiation of this one, right, I get as minus 3 e raised to power minus 3t, and this 3 cancels out, I get 1 e raised to power minus 3t. So here I am left with 1 only. So do I have 1? Yeah, I have 1 here. Okay, but what do I have here? If I see, this is minus 1. Okay, right, after differentiating and putting t equals 0, this is minus 1, this is plus 3. Okay, over plus 3, so this is 2 by 3. So no, this is not my answer basically. So my option A will satisfy. Okay, my option A will satisfy. So like obviously I was explaining it to you, that's why it took me so much time, but you will do this in like 30 seconds. You will do this in 30 seconds, right? So yeah, that's how you eliminate the options, right? So you first choose the easy targets and eliminate more and more options, then you choose between the difficult options, right? Yeah, the closest options. Yeah, that's how you eliminate the options. Okay, so yeah, that's where like just teaching like you gate and subjects is not enough. You have to know how to solve questions also. That is also very, very important, right? So yeah, this one is one of the things. So like that's how you solve by options. Okay, now let's use basically, okay, first I will write this method 1. Basically option checking, basically you use properties. Okay, so first property, simply phi of 0 was I only, so that was of no use. So you can directly jump to the second property, right? So the gate are people also smart, so they will not they will give us like first property to all the options. So second is phi dash of 0 equals to system matrix. So you use this property, right? Use this property. So method, what is method 2? The simple si minus a inverse, right? Find si minus a inverse and the Laplace inverse of this. So the Laplace inverse, right? This is phi of t, which is equals to simply Laplace inverse of this. So Laplace inverse I will do later on. I will do si minus a first. So what was my I? So I was this one, right? So what do I get? This is like s minus 1 0 and s plus 3. Okay, so yeah, this is s minus 1 0 s plus 3. So we have to take the Laplace inverse of this also, like yeah, first I have to take the inverse of this matrix, right? So what is the inverse? Right, this is s plus 3, this is s, this is 1, this is 0, and this is 1 by s times s plus 3. Okay, so you can solve it like this. So like you find the inverse. Okay, I will solve it for you. So what is this? This is simply 1 by s, and this is 1 by s into s plus 3, and this is 0 only, and this is 1 by s plus 3 only. So if I take the Laplace inverse of this I get as 1, and this is what I get. So this is like if I put s equals to 0 over here, I get 1 by 3. So 1 by 3, and if I put s equals to minus 3, I get like minus 1 by 3. S equals to minus 3, I get minus 1 by 3, and this is simply e raised to power minus 3t, right? So this I will not explain, you do. Okay, you understand, because I've explained it baby steps on many questions. So now this is 0, this is e raised to power minus 3t only. Okay, so what we see, this option is matching, right? Okay, 1 by 3, 1 minus e raised to minus 3t, and this is minus 3, right? So our option A is matching. Option A is matching. Okay, so this is not, this is 5t. So like without solving this, right, what you could have done is as we used to do, right, you multiply x of 0 here, then you find the x of t, right? So the second part, right, second part of the question, what was the question number? Basically 30, right? 30. So now though I will do it like this, like I have got 5 of t, I will multiply x of 0, but what you should do, like what we did also in previous question, I multiplied x of 0 directly here. Okay, so my x of t, right, will be equals to 5 of t, 5 of t times x of 0, right? So this is my 5 of t. Let me copy this. One zero, right? Okay, no, not 1 0, minus 1 and 3. Okay, also, right, like the main important point here to notice, like we have to find with respect of this input also. Okay, we have to find with respect of this input also, so that will be a bit difficult. First I will find with respect of this state state variable. So this is my zero input response. Okay, this is my zero input response due to initial values. So if I copied it, I've forgotten to copy it. What was this? This was minus 1 3. This is 1 times minus 1, this is 1 times 3. So what does this become? Minus 1, this is 1 minus e to minus 3t. Okay, so okay, sorry, I have to add this here only. So yeah, this becomes e raised to power, okay, this is minus 3t, and this is 0 times minus 1, and this is 3 times e raised to minus 3t. So this is 3 times e raised to minus 3t. So from here, right, you can, if you see from options, so there is this e raised to minus 3t, only here, right? So if I add with the unit step input, so this may come, okay, this may come. All the other options are not showing here. So this is the, what do you say, this is the zero input response, you can say. So you can take it here, okay, you can take it here, but obviously we don't want to take risk, okay. It may so happen that the input zero state response response to the input maybe something that cancels out here, okay, that may happen, okay. So yeah, so generally you don't want to take risk, okay. So that is the thing. So for finding the zero, this is the let me name this x1t, okay. For finding the zero state response, how do you find the zero state response? Basically, right, a zero state response will be simply this si minus a inverse only phi of s times b times u and the Laplace inverse of this, okay, Laplace inverse of this. So like I hope I have the phi of s here, where I have, yeah, this is the phi of s, right? Yeah, this is the phi of s. So what I'll copy this one, multiply this with b, basically this, right, 1 comma 0, and I will do the Laplace transform of u of s. It's a unit step, so it will be 1 by s, okay, just a scalar thing, and I have to take the Laplace inverse of this whole thing, right? So if I multiply like 1 by s times 1 and this times this, so this becomes 0 only, this is 1 by s only, so the first term becomes 1 by s square only, this is 0 only, and this is 0 only, right? So this is second term becomes 0 only, okay. Like 1 by s I have already multiplied, right? 1 by s I have already multiplied, okay. So I take the Laplace inverse of this, yeah, I get that C option only, right? So this is t comma 0, okay, this is t comma 0. So now right, now my total response state variable x of t will be equals to x1 of t plus x2 of t, okay. So this is the zero input response and this is the zero state response. So now if I write this in matrix format, I have basically this t is here positive, and I have minus e raised to power minus 3t, minus e raised to power minus 3t, and denominator I have 3 e raised to power minus 3t, and here I have 0, I have 0, right? So okay, so I get basically this solution. This is x2 of t, okay, this is x2 of t. So yeah, this is my answer. So what is the option? Option, I think it is C, right? Option is C, right? So C option, okay, option is C. So like what else can you do? So you can do like as I told, right, zero input response you can do. You can put t equals to 0, and only the x of 0 effect will be there, right? So if you do that, like that also you can do like that. The first first was the intuition, basically. If you find the zero input response and you see, yeah, this is only coming in addition, that you can do. The first, this second method is conventional method only, okay. Just find the zero input response, zero state response, add those two, use superposition. And method 2 is again check options, but put t equals to 0. So if I put t equals 0, what will I get? As my input is unit step, okay, so at t equals 0 I will only get 0 input response. I will get ZIR, right? I will get ZIR. So from ZIR, like what is my x of 0 for option A? For option A, my x of 0 is, okay, the options are very far away. I'll copy these options and replace them here only. I have to delete few things, so just wait. Okay, so if I put x of 0 here, okay, this is 0 and this is 1 only, right, and this is also 1, so I get minus 1 1, this is 0 and this is 1 only, and this is minus 3, so I get minus 1 minus 3, and this is 0, I get 1 over here and I get 3 over here, right, so this is 1 3, this is 0, I get minus 1 and I get 1 over here, minus 1 and 1, so minus 1 and 3 I get is a 0 state response. So let me check, right, what is the quotient, like quotient, in quotient, right, it has given a 0 state response, this is minus 1 3, so x of 0 should match with the 0 state response, the quotient has already given us. Okay, so yeah, like that also you can solve. So it is very important to understand like what tricks you can use, right. The first like the first basic trick was it's addition of those two. Okay, you can use this term only. Okay, that is one first trick. Second trick is basically conventional, not trick, method, conventional only. And third method is you put t equals to 0 and you check you check x of 0, you check x of 0, what is the 0 state response. The question has already given a 0 state response, use that. Obviously it should satisfy this equation, right, it should satisfy, then how else it will be the solution of this equation. Okay, that's why. So in this I have to write this state transition solution also. I can write state transition solution instead of equation. Okay, so this is also gate equation basically. So as they have written equation, so I write equation only, but you can say it's solution also. So yeah, we have another question also, which is also like a very important question. Okay, so this is the 31st question and the last question basically. So in this question, right, we have to find the like state diagram is given, a state equation is given, we have to find the state variable equations, right, to find this. So in the like end of the lecture I gave you one hint that this is minus 1 and 1, so all these are same, so we can write x1 and x2. But important is where is x2 and where is x1. That is one important point to note here, is that because like this is not like this, like 1 by s generally comes over here, right, but the loop is this, like this flow. So here we will have our something x1 and x dot, and here we will have our x, because we're integrating over it. Okay, we're integrating over it. So this one will be a bit difficult, this one will be a bit difficult to understand what will be my x1 and what will be my x2. Okay, so what I can do for now is like okay, that this is difficult, so can I write this in terms of output. Here also I have x2 like whatever x dot also. Okay, x dot. So yeah, this is not in terms of x dot, this is in terms of state variable only. So one thing I can observe is like, now let's do it by seeing the question only, So what you have to do, you have to assume like here some x dot and x, and here some x dot and x, right. So what you will do, you will remove this 1 by s terms, and I have taken effect of initial conditions, those are removed. This is x dot and this is x, right. Okay, so now I have to find the output in terms of this x and in terms of this x and u, right. So I will just find in terms of the first, right. Okay, I will not do this. What I will do is find this x dot in terms of u, right. That I will do in terms of both of these u. Here is one x, here is one x dot, and here is one x dot. So like I will write all this, but let's do it orally right now. So this is x dot. So what will happen due to this, right, I have a forward path gain of 1 minus 1 1 minus 1, so 1. Okay, and these loops are removed, right, so we don't have loops. So this x dot by u equals to 1 only. So what will be my this x dot, the number 1 or 2? This will be my 2, right, this will be my 2. Why? Because like I'm getting plus 1 only in x2, right, x2, basically x2 dot, I'm getting plus 1. So this will be my x2 dot, and this will be my x2, and this will be my x1 dot. That's how you can orally understand what will be my x2 dot and what will be my x1 dot. Okay, you can orally solve this also. That you found out this one, or like orally solving this is difficult. Okay, but you can understand what to pick as x2 dot and what to pick as x1, or what you can do, you can pick any x2 and x1. What will be the difference? These rows, right, these rows will be just interchange, okay, that will be just the difference, because x1 will be equals to like x1 will be swapped by x2 and x2 will be swapped by x1. So these rows will be just interchange, these rows, right. Not these rows, the answer that you will get will be interchange. Okay, if we don't assume our x1 x2 as this question has assumed, or the as like whoever said the question has assumed, right. So from here I understand this is x2 dot. Okay, this is x2 dot. So yeah, now I'll draw the state diagram and assume the right hand side to be x2 dot, right. So that is important. Also this is important that this is one by s and not this one. So this time, right, that the question has came a bit tricky. That's why this will be my like x dot, and this will be my x simply, as we are integrating. Okay, so you have to understand that. So very very important, like two things came out of this question. So this is this 1 2 3 4 2 3 4 and 5, right? This is -1. Okay, is this -1? No, this is 1 only. This is 1, this is -1, this is 1, this is -1. Okay, this okay, I'm doing something wrong. No, I'm not doing something wrong. This is okay. We have only 4 nodes only. Okay. This is only 1. Okay, sorry for like this is 1 by s only, and this is also okay. Okay, that's what I was doing wrong. Sorry. This was 1 and this was -1. I had another so this is again 1 by s. So what I told you, I will assume this as x2 dot, and this as x2, and this as x1 dot, and this as x1. Okay, now what I will do, I will simply like remove the like 1 by s terms, as I've already taken the effects. Initial conditions are already gone, right? Initial conditions are already gone. So remove these two. Okay, also, right, there are multiple forward paths to this x1 and x2. Like we have input, we have this x1 also. Okay, for this x2 we have this x2 also, we have this x1 also, and we have this input also. For y we have everything, right? We have this x2 also, we have this, sorry, not this one, this x2 also, this x1 also, and this u also. So yeah, we have to use that SFG formula, right? That SFG formula. So let's find the first equation. X1 equals to what? X1 equals to what? So first I will see the effect of x1 dot. First I will see the effect of x1 itself. X1 dot by x1. Okay, there are no loops, so don't worry, just worry about the forward path gain. Is there any forward path or not? Okay, so there are no loops, so this x1 dot, right, I am getting only through x1. Yeah, I have 1 -1 forward path gain, so I'll get -1. Okay, I will get here as -1. Now is there any other? So let's see x1 dot for x2. Can I go from x2 to x1 dot? No, this is in reverse direction, so 0 forward path gain. Now where I will go? I will go from simply this one, right? X1 dot from u. So from u, right, 1 times -1, so my gain is -1 only. So let me name this as x1 like dot dash, double dash, and triple dash. Okay, so my overall x1 dot will be equals to x1 dash plus x1 dot double dash plus x1 dot triple dash, right? So my overall x1 will be equals to minus x1, okay, due to this one, 0 and minus u. So it will be simply simply minus x1 plus minus u, right? Minus u. Now what will be my x2, right? So let me again copy this, copy the same thing only. I just replace few things. Let me take a new page. x2, okay. So now x2, right? This is x2, this is x2, this is x2. Due to x1, I am getting a gain of minus 1, 1 times minus 1. So I am getting a gain of 1. So this will become 1, okay. Due to x2 itself, I am getting gain of, like here is x2, so I am getting gain of minus 1. So this becomes minus 1. And due to u, right? 1 times minus 1 times 1 times minus 1. I am getting 1. So this is plus 1. So if I add x2 dot of t, so this is x2 dot dash plus x2 dot double dash plus x2 dot triple dash, okay. So what do I get? I get here, like this is x1, like this is x1, like x1 dash, x2 dash is x1. So x1 plus this is minus x2, okay, this is minus x2 plus this is plus u, right? Plus u. So this is plus u. So my x2 dot equals to x1 minus x2 plus u, okay. Now let's this is a state equation. Now let's do the output equation. So again, like copy and paste this one. Now we'll find the output equation. So what will be my y equals to, okay. So my y, right, change this to y, okay. Y dash, y double dash and y triple dash, okay. So if I change this to y, basically, right, y equals to, like u is 1 times minus 1 times minus 1, 1. So I get here like y by, okay, I need to change this, okay, I need to change this. So due to x1, right, due to x1, what do I get? Sorry for the interruption actually. So this one is simply x1, right? This one is minus 1, 1 times minus 1, 1. So this one I get here is 1, okay. So this one, right, this one, what do I get? This one x2, right, x2 is minus 1 times 1. So this one is simply minus 1 only, okay. And this one, like with respect to u, 1 minus 1, 1 minus 1. So this one is plus 1 only, okay. So like my y, this is y dash plus y double dash plus y triple dash. So what is this equals to? This is equals to x1 plus, okay, this is minus x2 plus, okay, where did I go? Plus u, right? So my y equals to x1 minus x2 plus u, okay. So this is what my y is equals to, okay. So yeah, this is what my y is equals to. So let me write the state space equation right now. So this, right, my x dot will be equals to what? This equation. So what is my x1 dot equals to minus x1 minus u. So this will be minus 1 comma 0, and this is 1 comma minus 1, okay, 1 comma minus 1, and this is simply, let's say this is x vector plus, this is plus 1, and this is minus 1, and this is plus 1, right, plus 1. So minus 1 and plus 1, okay, minus 1 and plus 1. So now, right, what do I see? So if I just check the options, right, if I just check the options, so this is into u, and what is my output equation? Output equation is this one, right, this one. So this is 1 minus 1 times x we have U also. This time the D matrix isn't 0. Okay, this time the D matrix isn't 0, it is 1 only, right? So it is only 1 times U. Okay, so yeah, what is like what option is matching here? Like if I check this, right, if I copy and paste the options here, okay, so what I am saying is this option A, right, this option A is matching. Okay, minus 1 0 1 minus 1 minus 1 0 1 minus 1 minus 1 and 1 minus 1 and 1, this we already calculated ourselves in like by orally, and this one was 1 minus 1, this is 1. Okay, so 1 minus 1, this is 1. Okay, so yeah, option A is matching. So option A is matching, so I'll solve this here also. Option A is matching. And the what will be basically state transition matrix, you do the SI minus A inverse. Okay, you do the SI minus A inverse, or like method, what will be the method 2 of this one, like method 2 of this one. So method 2 of this one, right, is calculating the transfer function and check options, like do SI minus A inverse of all the options, do SI minus A inverse of all the options, right, do SI minus A inverse of all the options. Okay, so yeah, this is what the method 2 is. So you check and you see like okay, you have to multiply C also and B here also. Okay, okay, so this is what you have to do. So yeah, like this one you can do, right, like if you do all of all options, you see which transformation is matching with the this SFG, right, you calculate the SFG transformation and from there you understand. Okay, so the second is find the state transition matrix. Can we do this orally? If I put t equals to 0, again you might see that yeah, gate people are smart. Okay, they are not smart enough, this is wrong and this is okay, this is correct only. So this C is eliminated, but these three options are there. Now what I have to do, again I have to be more smarter. So phi dash of 0 will be A. So A I have found out, right, from here. So from here what I see is, if I do phi dash of this one, right, phi dash of this one, so this is minus 1 is what is minus 1 I get. Okay, this is correct only, this is 0 only. Now this is the only problem, right, this is the only problem. So what is the differentiation of this one? So I will do differentiation by parts, basically u times v, u v rule. So first one will be e raised to power minus t and second will be minus t e raised to power minus t. Okay, so this comes out to be, if I put t equals 0 here, this is 1 minus 0, so this is 1 only, which is matching, right? So option A will be my answer. If I do this, this will be just a negative sign of this, so this will be minus 1, so this is not matching and this is also not matching. Okay, as there is 0 and here is 1. Okay, as here is 0 and there is 1, so that's why this option won't match. So like if you didn't understand how I got here, let me explain this to you. Simply what I did differentiation of t raised to power minus t, and this is what I got. Then what I did, I put t equals to 0. Okay, so my answer will be option A only. Okay, my answer will be option A. Okay, so like for the like the part 55th, okay, this is not the 55th question for us. What question is this? Whatever question is it, part B, what do? You use the property of state transition matrix, phi of 0 equals to I and phi dash of 0 equals to A. So from here you see that our option A is matching. Okay, so this is the answer. So this is the end of this lecture. So I will not give you a quick revision. Revision is for you because these questions were all revisions. You already knew all these questions because the concept have already been taught already. Okay, just you have to revise by yourself if you weren't able to solve this question, right? So yeah, thank you for watching the lecture, and next lecture we'll start a new topic, not chapter, new topic. Okay, thank you.